This is Greg Pasternak from Riverside Life, and today I'm going to be sharing with you lessons on how to use the 9 county San Francisco Bay Area classification so you can go to any site in the Bay Area and determine what the stream type is there. You don't need me to tell you, you can do it yourself. So let me show you how to do that. These are the lessons to aid users to determine stream types in the San Francisco Bay Area. And as always with this series of presentations, I'm going to acknowledge Dr. Jihao Wang, who has been lead analyst in helping me to develop the stream classification. Many people participated in data collection, and this is a 7-institution collaboration funded by the University of California Office of the President through the state of California. So in this presentation, I want to talk about artificial shape. It basically comes down to the simple question in red: were the rivers, banks shaped by humans? Done. So how do you decide that? I mean, obviously you're not there. You don't have the plans. You weren't there at the time. You have to kind of figure that out. Well, for sure, nature doesn't produce trapezoidal banks. And I'm not going to say that it doesn't exist somewhere in the world, because that is always a peculiar river. But for the most part, when you see those just very flat, smooth banks with like a 2-to-1 side slope or something like that, then it's artificial. Sometimes you'll get triangular shapes, usually triangular. It's not common to see triangular canals, but they can be there. Rectangular is not common with natural bank materials in terms of an artificial shape, because no one wants to dig a vertical bank because it might collapse, which creates liability issues or just is poor engineering. So if you see something that's quite vertical, like in the right, there's a lot of vegetation here. There's pretty steep banks, but when they're that vertical, they're probably naturally entrenched. If humans are going to engineer vertical banks, they're pretty much going to put some kind of bank composition on there to protect it. So the indicators here: look for straight side slopes, typically at an angle, but they can be vertical if they're supported, buttressed. Don't get hung up on vegetation. If you see vegetation, that doesn't mean it's natural. You could have a canal that was dug 20 or 30 years ago and it's covered with weeds or willows or something. The presence of vegetation does not tell you anything about artificial shape. Also, you may see that the river is naturalizing, right? We have this naturalizing type. So maybe there's been some bank collapse, but if it is shaped and then it's changing, but that original shape, you see that presence of it, then we're going to focus on that. So let's look at some simple examples. So here in the upper left is a relatively large canal. There's even an additional wall over here. But you can just see that trapezoidal shape on both sides of the bank, relatively flat bed. This is probably just your A4 large canal kind of site. Here's a very common drainage ditch. In this case, although it's hard to tell visually, there is concrete along the bottom of this. And so this actually would then be a bank protected canal, or it could be entirely an armored channel. I don't remember which for this site. But you also have to factor in for floods that you could be hitting these fences. You're on the sidewalk, so all of that is there. Here is another example of a ditch. It has a relatively flat bed, and you can just see these artificial shaped sides. Because it's less than 2 people high, you can kind of see how high the person is standing here. It's about 1 person height high. So, this is probably A6 ditch. Here's a very deeply entrenched, like a very big canal. You can see from the size of a car how far down it is. It looks like it's just natural material on the banks. I can't tell entirely because of the vegetation. But anyway, clearly artificial shape. Now, if you have an entrenched channel and then someone comes in and blasts shotcrete on it, they're essentially deciding the shape of the river. So any bank protection that's there automatically means that it may have been natural, but once you put that protection on, it's an artificial shape. Here's a small ditch. Okay, so let's say you're at a site and you're struggling to decide if you're just at a deeply entrenched natural river or if you're in an artificial channel. One of the things I've seen is just bring up on your phone Google Maps and take a look. I mean, when you see a long, straight section, it's a good chance that that has been artificially channelized at some point. So that's one thing that can help. It's just something you can see from the air that you can't always see from the ground. Now, here's a really important issue. You go to a site, it's 200 meters long. What if 20 meters has artificial shape, but not the rest? Or, every, I don't know, 50 feet or something, there's a structure there. It's not continuous. So we've made the decision. And again, like in science, a lot of times you make an arbitrary decision, but it's a decision with a real purpose. To be considered an artificial shape, more than or equal to 50% of the stream length for the 200-meter length, or of the observed cross sections where you are within that, more than half of it has to be artificial shape, then it's an artificial shape. So when we talk, because rivers have two sides, you have to factor that in. If one whole side all the way down is artificial and the other whole side isn't, it's artificial. That's 50 or greater. However, if only half of one side is artificial and the whole other side is natural, now only a quarter of the length of the two sides is. So we're not going to call that an artificial shape. That's just, a manipulation to what is otherwise a natural channel. So 50% is the threshold. This threshold pretty much is the standard we've used for the whole site. At the moment, we don't have a process basis for that per se. It's simply a definition that we're laying down, and it's something that could always be reassessed in the future. Okay, so what happens when you have a channel that has been artificially created by engineers, but it starts to naturalize? Like it's 50 years later, floods have come through, maybe some beavers came in for a while. I mean, who knows what. And so like in this photo, there's a very well-defined trapezoidal bank to the floodway on the left here. And then in the back on the right, it's there as well. So you've got trapezoidal floodway, you've got a like really flat, smooth floodplain surface. And then there's an inset base flow channel that was engineered in there. But over the decades, what has happened is that this inset channel has begun to entrench a little bit. It's starting to meander. The banks have collapsed some. Emergent vegetation has come in. So this is what we call a naturalizing channel. And on the left, I've just drawn a little, simple schematic of the photo that's on the right. Just because the channel, like the base flow channel here, is naturalizing, it doesn't turn it into a natural river. It's still an artificial river. We have a type for this if there's no bank protection at all. And I think if you're in the deeply entrenched category, it's going to be the A3 type, I believe, which is your naturalizing artificial river. This also just makes the point that over time, the stream classification can change. So just because it's a whatever type now, 10 years from now, if something changes dramatically, it could change to a different type. Or if someone comes and does a stream restoration, that might change it to a different type. Inset structures do not count towards, defining the channel type. So because a structure, when we go back to our 50% threshold, like say, take the bank composition criteria. Well, okay, here's bed composition. Here is artificial bed composition, but it's only a small fraction. So, when you stand at a bridge, that's when this is really going to be an issue. Because when you stand at a bridge, you may be seeing a short section of river that has been engineered, right? So if it's just engineered at the bridge, but once you get around the bend or something, then it might change. You have to be mindful if you're at one location. First of all, don't trespass to go see other locations if it's private land, Or if it looks unsafe because it's deeply entrenched, don't take your life in your hands. Oh, I gotta get this stream type, right? I mean, unless you're a professional and you know what you're doing, stick with what you can safely see from where it's safe to be. But if it's safe to stand on a bridge and you're looking, and then you cross the street and you look across at the other bridge, you got to look away from the bridge itself. Maybe you'll just see some riprap. Like there's a little piece of riprap here. Riprap is a term meaning these like stream bank protection with large boulders. So here's some large boulders that are here, and yeah, they're that's just a localized little thing. So you have to look away from what these individual sites are. Again, using this 50% threshold as what matters. Again, if you can't see enough to make a decision, then don't make a classification for the site. Or if you make a decision, you can always choose the high uncertainty option when you're making that decision. I would generally say to avoid classifying stream restoration sites. I mean, this is like a photo I got from the web of Cordonesis Creek and kind of like the Berkeley area. I mean, at the moment, if I was going to classify it, I mean, look, it's an artificial channel. Well, like it or not, I don't know. Maybe you can. I mean, it's probably going to classify as A6 ditch because it's probably been made less than 2 people high. If it's bank protected, I'd have to take that back. If it's bank protected or hardened, then it's gonna classify as our one of our bank protected types. Probably, I'm thinking that would be maybe A5. But again, that would have to be for more than 50% of the length. Otherwise, it's probably just going to be like a ditch. So it's a stream restoration, but it's entirely artificially made. But just goes to say, like, you may not want to classify these stream restoration sites. Now, what is the hardest situation for bank shape? I can tell you we've had a lot of experience already. And it's the situation with what we call urban stream syndrome. So, urban stream syndrome is a model of channel evolution that says that if you start in a natural setting and you have a small channel adjacent to a floodplain, your sort of classic, well-connected channel floodplain, then when you start to urbanize, because you're preventing water from infiltrating into the ground and evaporating away, you now have more water than sediment, and that drives entrenchment. So it starts to go down. The more it entrenches, the more water it takes to spill out of the channel, generating more force, driving more downward entrenchment. So you may be in a situation like this stage 2, where it's still relatively narrow, but you have essentially vertical walls that are more than 12 feet high. In that situation, it can look like those are artificial, but man, I'm telling you, when it's that vertical, people don't build canals like that. People set the banks back because of safety and liability reasons. And you don't want to engineer something over steepen that's just going to collapse. You want to engineer something to last. So you're probably going to engineer a trapezoidal shape. And as a result, if you see these steep banks like this, then it's probably urban stream syndrome. Over time, as the banks collapse in urban stream syndrome, you get to stage 3 where it's wide and deep. And at this stage, typically, like somewhere between stage 2 and 3, a lot of landowners, if there's private land or civil infrastructure that needs to be protected and public lands, you're going to see a lot of bank protection coming into this location. And that probably already happened historically. So in urban stream syndrome, insides rivers often have vertical banks in response to systemic human impacts. That does not make it an artificial channel. This is a natural channel. I believe we have N4 is a deeply incised channel type, and N6 is a deeply incised channel type. N4 is your coarse sediment, N6 is your fine sediment. So if you have a deeply incised river, it's going to be an N4, N6. That's what it is. But I've been in cases where, like, if somebody starts off looking at a lot of agricultural ditches and canals, and then you come into suburbia and you see these deeply entrenched rivers at the agricultural suburban fringe, your mind is on the A4 artificial canal, or maybe our A5 bank protected, a bank hardened canal, then you may not realize, but it really is urban stream syndrome and it's a natural channel. So you have to decide if the banks are vertical because they were engineered that way, carved by people, or if they naturally became vertical. And in most cases, again, I'm not going to say in every case. I mean, who knows what people do, but and I guess I would say I have seen meadow restoration projects where they've used excavators from the side in really cohesive sediment and made vertical walls. But for most cases, if you see it being that vertical, it's probably going to be an urban stream syndrome natural stream. But you just have to make that decision. It's not me. I'm not out there. You're out there. You have to make the decision. If banks are hardened, in other words, if there's any sort of composition material that is artificial for more than 50% of the length, considering both sides, then if it's hardened, it's artificial. So it may have naturally incised, but the minute they put that bank protection there, they're choosing the shape with gabion structures, stitch piers, shotcrete, like whatever they're putting in, they're now controlling the shape. Therefore, it's considered artificial shape if it has artificial composition. Here's some examples from urban stream syndrome. So on the left is a natural channel, has naturally steep banks. This is actually not even an entrenched river. This is a confined river. So you just see the hillside. So that I'll also talk later about the difference between confinement and entrenchment. But in this case, you're looking at it and you feel like, gee, is this artificial? I mean, it is a trapezoidal shape, but no, this is an entirely natural setting. And you look at the left bank in particular, how varied the surface is with these, roots and undercuts and all this. Like that's a very natural hillside. On the right, we have a deeply entrenched river in Contra Costa County. It's just 30 or 40 feet up to the valley floor. So this is all entrenchment. This is not hillside. That's the thing. You look at these two photos over here, this is just going to be a mountain. Over here, you come out and you're at somebody's house. It's like the valley floor. And what you can see, though, is that even though it had a natural incision and widening process, once they put these giant pieces of cement slabs along the bank, they're now defining an artificial shape and composition.